Today we will discuss about how to represent the transition table. So this is a given DFA. So here you are having the three states Q0, Q1 and Q2, and you are having the input alphabets, that is 0 and 1. So for the given whatever the given DFA, for this DFA we need to draw the transition table for the given DFA. So you can see the DFA, you are having the three transitions. You are having totally three states Q0, Q1, Q2, and you are having two symbols, and let us see that Q2 is the final state. You are having two input alphabets, one is 0 and another one is 1. So when coming to drawing, the representation of DFA will be like this. First you can take Q equals to the set of states. You can take the set of states. Q equals to, you are having Q0, Q1 and then Q2. So you can see the same, you are having the number of states Q0, Q1 and then Q2, and the next sigma. So sigma equals to, you can take 0 comma 1, means these are all the input alphabets. These are all input alphabets, means you are having 0 and you are having 1. So in the same way you are represented sigma equals to input alphabets of 0 comma 1. So Q, it is Q0, Q1 and then Q2. Sigma equals to 0 comma 1. So this is the input symbols we have taken. So for this given input or the given DFA, we need to draw the transition table. So now you need to go for the transition. So that you are representing it as a delta. So you can represent it as a delta of Q0 comma. So you can see the diagram again. So Q0 on 0, it is moving to Q1. Q0 on 1, it is moving to Q2. So Q0 comma 0 transition implies to Q1. That's what the transition functions. So write the transition functions. Q0 on 0, it is moving to Q1. Q0 on 1, it is moving to Q2. So there's the functions from the Q0. And coming to the Q1, you can see Q1 on 0, you are moving to Q2 and you don't have any other functions to Q2, and you can add a self loop from Q2 either to 0 or 1. So you can add like that also. You can Q1 to, you can, is an optional. If you want to add, you can add, otherwise you can remove. So Q0 is over. We are moving to Q1. So whenever you're writing Q1, so see delta Q1 comma 0 is moving to Q2. If you are taking self loop from Q2, delta Q2 comma 0 is moving to Q2. On the same way, you can write delta Q2 comma 1 is also moving to Q2. This is the transition functions for the given DFA. So for this transition function, now you need to go for drawing the transition table. So you can take the transition table like this. So here you can write Q0, Q1, Q2. So whenever the list of, these are all the list of states we need to write here first. So the starting state, the start state will be represented with arrow, and the end state will be represented with circle. So this is the main important thing whenever you're drawing any transition table. The start state represented with arrow and the end state represented with circle. So the input alphabets 0, 1. So you can see Q0 on 0. So based upon the transition functions, Q0 on 0 it is moving to Q1, Q0 on 1 it is going to Q2. So you can Q0 on 0 it is going to Q1 and Q0 on 1 we are going to Q2. So this you can write it as Q2. And come to Q1, delta Q1 on 0 going to Q2, Q1 on 0 going to Q2, and you don't have any transactions on Q1 on 1. So on Q2 to 1, so Q2 on 0 going to Q2, Q2 on 1 it's going to Q2. So we can write Q2 here as well as Q2 here. So this is the way to represent any deterministic finite automata or non-deterministic finite automata, or whatever the finite automatas they are represented, that all the finite automatas you can represent by using the particular procedure.